Hello, I'm going to explain you how to use HELIO, the Heliophysics Integrated Observatory web interface. To access to it, you have to go to http://hfe.helio-vo.eu. In this web page, you will find out that you have three main options: search events, search for features, which in the moment is disabled, but I will explain later how to connect through the search feature catalog webpage, and search for data. In this screencast, I'm going to show you how to find out an event observed on Earth, on Mars, and its origin on the Sun. So to start with, we are going to search for event. And in here you have two dialogues. One is search for time, and the other is to select an event. First, we just clicking on the time dialog, we get a pop-up where you can choose which time you want to select. We're going to choose the beginning of April of 2001 for this use case. So we select 1st of April till the 16th of April of the same year as I'm showing. 16, and we click OK. Now the time appears in the box just beside the time dialog. Now for the event list, we proceed in the same way, and here we can have the following. We can search for event type, for location, and for observational type. This checkbox will filter the selection of different catalogs that we have below. So it makes it easier to find out what we want to do. So in this case, we want to search for solar wind and measure in situ. In here, one of the catalogs, it's the Soho Celia's MTOF PM Interplanetary Shock List, which contains the dates that we want to observe in. We click OK, and we submit the query. After a couple of seconds, we will get the list of that catalog. Here it goes. Yeah, it tells us the name of the catalog that we are querying, and the number of results, in this case 6 results, and the list of the events that we have found in that time range. In particular, I'm interested in this one, which happened the 4th of April of 2001. The origin, it thought to be the active region 9393 after a X20 flare, and it tells you where it was and when it started and the time that it took to go there. But for now, we are going to just get the time and proceed to see if that flare it could have been the cause of this event. So first of all, we can extract the time. As you see, when we click in that button here, we get the same dialog for the time selection. But this one is to save a time on our data card that I will show you in a second. The name, we can call it Hit Earth. And we click OK. Now, as you see, now we have a new icon up here with the times that we saved. Now I'm going to save it again, but in this case I'm going to change the time a little bit. I'm going to add 4 hours before and after. So we get a time range of 8 hours. We call it Heat Earth Interval. And we get the second icon up here. Now, what I want to do this, I want to do this to show you that we can also plot certain data sets. In this case, I want to plot a timeline with the time range that we produce right now. If I would have used the other one, it would be just a single time, and we wouldn't see what happened before or after. Now we get the ACE plot, which it contains different parameters. It contains the magnetic field. We would say that it was around 6 Teslas and it changed almost to 25 Teslas, nanoteslas, excuse me. We can also see the different components of the magnetic field, Bx, By, and Bz, and we can see how them switch. And this could be an indication of a CME going on. Also, we can see the velocity and in here, and the density of the particles that this shock brought. In this case, the velocity was around 500 and suddenly it reached almost 800 kilometers per second. Now we are almost sure then that it's a CME. So we want to search or to find out which CME produced this thing. For that, one of the tools that HELIO provides you is the kernel mass ejection backward propagation model. It also provides you other propagation models, all of them based on a simple ballistic propagation model. So clicking the backward and providing the starting time as the heat air time that we saved previously, we clicking on the parameters, we get either we want to choose which planet to start from or a spacecraft. As you can see, in this case we select Earth. We select a 800 kilometers per second plus minus 100 and a longitudinal width of say 100 degrees. For this case it doesn't really matter because we are going to go backwards exactly to the sun in a straight line. Clicking submit, it runs the propagation model and it will provide us with a number of plots and a table where it tells us either which planet has heat and the times. So as I say, we have 3 different plots for inner planets, other planets, or even farther away where we can see Voyager 1 and Voyager 2. Clicking on them, we get a zoom in of the plot. And in this plot is quite straightforward. We have the planets and they are labeled down here what the color means. And the color underneath, it kind of simulate or reference to the CME, and the color gradient, it tells you either how many days it took to get to this point. So we see that actually Venus, Earth and Mars were in this range for that CME, and it took roughly 2.2 days to get to Earth. Now going back to the table that we also got, we get the time where the Earth, where the Sun, where the CME started on the Sun, and the velocity error that we input, it provides you a mean and maximum heating time on delays on the Sun, on the Earth. Now clicking here to track the times, we get the time of the Sun. Now just to be aware of the error, we can save here the error as a whole day, and let's click OK, and I didn't name that time, but we can click here and edit and modify the time that we have saved. So in this case we can put Sun range. Saving it, it will save here the time as we want. Now we want to search for events that happen on the Sun, so we go back to the same dialog that before, and in this case we drag and drop the time of the Sun. So we have here Sun range, and we want now to change the catalog, so we clear and select them again. And in this case we are going to search for CMEs. So for example the Soho Lascaux CME event list, and why not also the Cactus Soho Lascaux CME catalog. We get them up here, but we also want a flares, so we can get to see if either they were an X20 flare at that time. As you can see here, the ones that you click on them, you get them loading here. If you, for any mistake, you want to remove them, you just have to click on the X button on the left hand side. We save now these three lists, we submit it, and after a couple of seconds we get the three catalogs as three different tabs. Here is the original name, that internal name of the catalogs that we use, and the number of results that we get from each of the catalogs. First we get a LASCO CME catalog list, and we are interested on HELIO CME because it seems that it comes to Earth. So PA width, it tells us if we hover the mouse on top, that is the position angle width of the CME. Now there is one that is very wide, and this is the one happening at this time. We can check also in the Cactus Soho CME list. Following the same procedure as before, we sort the catalog by PA width, and here we get two HELIO CMEs. Which one we choose? Well, comparing with the other one, it happened around 10 at night, so most probably it's this one. Nevertheless, we get links to the Cactus data products, and here on the right hand side we can click there and it loads the CME list, and we can see here at what time exactly happened that one, and we can pause that time in the video, and we can see that CME that they refer is at 22:26, which is the same one that we saw on the other catalog, on the Soho LASCO CME. And finally we can search for X flares. We can sort here X-ray class. Clicking twice, we get that there is an X20 flare, which it happened around 9:32 of the same day, as it happened previously with the other CMEs. So now we can save that time. We can extract the time for the CME, for the ghost X flare detection, and we get the start time and end time of the flare. Now, for the purpose that I want to do it now, I'm going to expand this till the end of the day. Done, and we call that sun start range, as we want a range time for the next step. Now we have the sun start time range. We can go back to the propagation model and trying to forward the CME to find whether Mars has been hit or not. So we drag the sun start time, and as the parameters we're going to choose a zero longitude, 100 width as before, and just for the sake of be sure, we're going to put 1000 plus minus 500 kilometers per second. Submitting this query, we will produce the same plots as before. One for the inner planets, another for the outer planets, and finally for the farther than the outer planets as the Voyager 1 and 2. And it will produce a table with the planets that has been hit and which have been not. In this case, we're interested in Mars. And as before, we can save the times. Now we have here a little problem because the times that it's saved by default are the time start, and the one that we want is the estimated time of arrival. In this case, we're going to look at the minimum time, which is the 4th of April around 6 in the afternoon. 6 in the afternoon. We can just leave the minutes there, and the final time we want is the 8th of April around 1 in the afternoon, 1:30. Now we save these times as Mars heat range. Click OK, and that will show us in our data card as before. Now we go back to search events to see if there's any event registered on Mars for that time range. As before, we drag and drop the time here. We clear the events previously selected, and we are going to search now if there's something related with Mars. We want something like semi and a planet, so we do this to filtering, and we find that there's actually a Mars event. If we wouldn't know where to select here, we could search in this box where to put Mars, and it will appear there which one is it. In this case, we will also find that the semi would have hit Venus, so we can search if there's something in Venus, but there is not, unfortunately. So we can search, we can save that and search for events happening in Mars in that time range. And surprisingly, there's an event that started in Mars around that time. So we can save this time range, or as we have got the time range from before, we don't need to save that one again. We could edit or update it or anything, but it's fine for our purposes because now we want to search for data. And to search for data, we use search again, but now we search for data, but we don't know which data we want to search. We don't know the instruments, and we don't know anything whether we are interested or not. So we can search first for capability, and we can say, okay, let's go backwards. Let's start for Mars. So we here set the time. This will provide us a list of properties that of an instrument that it are active during that time, so they were in operation. So in this case, we were interested in Mars, so we can click here Mars, and we have found 2 of them, so we can click them all, and we can extract either the time for those instruments, starting time and end time, or we can extract the instrument itself. So you see here there is the 2 instruments are here, and we can say Mars instrument or inst, and save them. And in this case it didn't work, so we edit them there, and we can Mars instrument again. Let's see if now it does work, and there you go, Mars inst. Now we want to search on the heat earth interval to search instruments that have been observed or measured things on Earth. And as before, now we can search, click here for Earth, so we filter the results. Let's see what the other tabs offer us. So we want something that observed in situ. So now, and we want, say, we want to particles, select particles. So we just click here and we filter the list for ones that are measured particles. We can start to search in here. We say, okay, we want ACE, EPAM, and for example, we want also the magnetic field, so for that we have to unselect the particles and select the fields. Oops. select the fields, and we want now also a Mac, for example, so that will give us almost the same thing that before. And we can extract this once. We unselect the bottom and we can extract the times or the instrument. In this case, we're going to extract the instruments, and we can say here earth instruments as well. Click OK. Earth instrument. And finally, we want to search on the sun star range, which was this other one here, sun star range. And we want to search for those that observe the flare and the CME. And we can just select the sun, and we say, okay, we want observable entity, we want X-rays, for example. And we go gauss. Say, okay, I want gauss. Now I want something that observe a spectrometer, so we can get Soho CDS, for instance. We want also a magnetometer. There's not magnetometers. There's magnetograph, maybe. And we have Soho MDI. Now we want to also observe the corona, so we can say, okay, let's see other corona, and we have LASCO. So we can save all those instruments as it shows here. We just rename it now. And we can here say solar instruments. Now we want to search for the data itself. Now we know which instruments and which dates we want to do. So it's straightforward. We just say, okay, for Mars, drag and drop, and submit. And that produces us the links to the data. Either we can click here, 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 and if we click there, it appears the dialog to download the data. In this case, I don't want to download this data. I want to maybe download them all. And so here is the two different catalogs that I got. In one I got 5 entries, in the other I got 0 of them. Or we could just download the VO table. The VO table, it provides us a file that we can use either from different interfaces to download the data. Similarly, we can do with Earth instruments. We just drag and drop here the Earth instrument, and you see A's appear in place. And the Earth time range. We submit, and as before, we get the instruments to download. There we go. And similarly with the solar instruments. The sun range, we submit so. And it produces the different values for the different instruments we have queried for. So that's been all. I hope you have enjoyed, and please use it and give us feedback. Thank you.